Our lab at IIT Hyderabad stands as Carbon Lab, which is basically creative and advanced research based on nanomaterials. Carbon Lab primarily focuses on the using nanomaterials for various applications, including the energy storage devices, healthcare applications like drug delivery, as well as the nature-inspired functional surfaces. In last few years, our group has started working on a new battery chemistry, which is called Metal-CO2 Battery. We have been awarded the Swaranajyanti Fellowship to carry out the work in this highly potential battery technology on Metal-CO2, in which we use the CO2 directly as an energy carrier to produce the electricity. And by conceptualizing this Metal-CO2 battery, we aim to solve two challenges in one single go. First, we are all aware about the increased CO2 emissions on the earth, and by utilizing this CO2 directly without converting into fuels or useful chemicals, we are addressing the emissions of CO2 and thus mitigating the enhanced CO2 effects like global warming or climate change. At the same time, we also aim to develop this technology for interplanetary Mars mission like India's Mangalyaan, because if you see the Mars atmosphere, which is full of CO2, so the idea is if we can utilize the CO2 atmosphere present in the Mars, then we need not to send the energy storage devices like lithium-ion battery or other batteries from the Earth for these missions, and that will basically primarily reduce the weight as well as volume and of course the overall cost of the missions.
So here is how we are making the coin cell. So this is how we'll crimp the cell. After crimping, we are putting into the terminals for the battery to be connected to the external circuit, and then we'll close the bottle to make the airtight gas chamber. So this will now be taken out of the chamber to be connected to the battery cycler, and then the analysis will be carried out. So the Metal-CO2 battery is housed into the bottle chamber. This bottle chamber contains the CO2 gas, which will go into the coin cell prototype and help run the battery. Now we'll connect it to a battery cycler, which will help in analyzing the performance of the battery for further use.
So further from the experimental part, we are modeling the batteries using ANSYS and DFT simulations so that we can see the thermodynamics of the battery and how the temperature and the environmental conditions affecting the battery performance, and other than that, the kinetics, what are the reactions happening in the system in the elemental level and microstructure levels. So that will be determining the future of battery, and also we can develop a battery system which is having a higher battery performance and more charge-discharge ratios.
We are the first in the country to start working on this Metal-CO2 battery, and in fact worldwide also there are very few groups who started working on this technology in 2014 onwards. Recently, in one of the very highly reputed chemical reviews paper, our work has been cited in the journey of Metal-CO2 battery as the first group which demonstrate its use in the Martian atmosphere for the interplanetary Mars missions. We were also encouraged recently to realize that our first paper in this Metal-CO2 battery area, which was published in 2021 in Materials Letter, has been listed as most popular article by the journal in last 3 years. We aim to take this work further with the help of the related agency like ISRO. All these developments have definitely marked our journey to the world, and we are committed to work on this technology further.